So this talk is the early British scientists' response was to reject Einstein's relativity theory, and that's meaning special relativity. This is the information source I will be going by. So in the book, it deals with the German and French scientific community's response to Einstein's relativity. Then Goldberg gets to the British response, and he says the British response to the theory of relativity during the years 1905 to 1911 had a different character from the responses we have analysed in Germany and France. And so Einstein's general relativity was 1915, so what we're talking about here is special relativity. For the first 2 years of the period, there was virtually no recognition of the theory in the literature. Following that, there was some controversy. Not as much as in the German literature, however, there was not the wide diversity of opinion, the elaboration, or the debate so characteristic of German response. The acceptance of the theory hinged upon making it compatible with the concept of the ether. As paradoxical as that might be, there was almost unanimous agreement within the British physics community about such a program. Almost all British physicists who worked in electrodynamics behaved in similar ways about these issues. So, i.e., the early British scientific community's response to Einstein's relativity was to reject it because it does not have the ether. So Goldberg clarifies things a bit better when he says the following. Whereas there was a widespread acceptance of the concept of the ether in the 19th century, the detailed investigation of the properties of the ethereal medium became a uniquely British enterprise. Work on the ether in Britain during the 19th century was concentrated in the Cambridge School, that would be in the Cambridge University, a group of mathematical physicists who studied or worked at Cambridge University and included George Green and so forth and others. Ether mechanics was the investigation of these unearthly properties and how they related to ordinary matter and radiation. The investigation was an all-consuming occupation to some British physicists. In the words of Arthur Eddington, one of the leading British theorists of the 20th century, he says, the 19th century is littered with debris of abortive ethers, elastic solids, jellies, froths, vortex networks. Then that's into that quote. It is then not surprising to learn that between 1905 and 1907 no notice was taken of Einstein's theory. As late as 1923, the physicist and later philosopher Norman Campbell wrote, "It remains an indubitable fact that in spite of the attempts to enlighten him, an average British physicist, the man in the laboratory, as I have ventured to call him, is still ignorant of Einstein's work and not very much interested in it." So the British physics establishment were only really interested in an ether theory. And this is the paper by Einstein in 1905 on the electrodynamics of moving bodies, where Einstein is supposed to introduce special relativity. In that paper, this is the troubling passage, and of course I'm ignoring the translation problems and going by the usual translation of Einstein's relativity. It says, the introduction of a luminescence ether will prove to be superfluous inasmuch as the view here to be developed will not require an absolutely stationary space, provided with special properties, nor assign a velocity vector to a point of the empty space in which electromagnetic processes take place. Einstein says superfluous, so that seems to mean discard the ether. And the British in 1905 to 1911 wanted an ether theory, so discarded his theory from consideration. Goldberg says the following: the concept of an ether, a space-filling medium responsible for the propagation of various kinds of forces, was not a concept of interest only to the British. It had been the French philosopher Descartes who had constructed the universe of light and matter of a type of ether, and in the 18th century natural philosophers on the continent, in Britain and in the United States, had made use of several different kinds of ether for the transmission of several types of phenomena whose propagation through space could not otherwise be understood. There is an electric ether, a magnetic ether, and a gravitational ether. It was not until the 19th century, as the wave theory of light gained acceptance, that a luminescent ether became important. Later, with the identification of light as an electromagnetic disturbance, 3 of the 4 phenomena, light, electricity, and magnetism, could be recognized as propagated within one medium, the electromagnetic ether. This suggested a research program in which scientists tried to unite gravitational effects with electromagnetic effects. This was to be part of Lorenzi's program. The possibility of a unification has been basic to much of natural philosophy. It motivates many of today's theoretical high-energy physicists. Now, I've dealt with various types of ether in other videos. The point to note here is the unification. You go in with the ether idea and you are unifying things. So an attempt was made to unify physics, and with the rejection of ether by Einstein, that prevented the unification, and that was in 1905. However, when we go to Einstein in 1920, he seems to be saying something different, and this is shown here as what he said in the 5th of May 1920. In that talk, he seems to be saying there's an ether, but it seems too late with the physics community locking itself into what Einstein said in 1905 with discarding the ether. Thus, attempt at unification gets blocked. Now, what Einstein says in 1920 about the ether is pretty hard to understand, because he's seems to be very vague and ambiguous in what he's saying, but he does seem to be saying there is some sort of ether. So what happens is that Einstein becomes famous in 1919 with general relativity, and with the ambiguity in which he writes things is that supposed to be the physics establishment accepting ether or not. And what seems to happen is the mainstream seems to tend to go with what he says in 1905 and interpreting that as no ether, and seems to ignore what looks like a change of mind by him in the 1920s, and with that have messed up a concept that seeks to unify physics. So trying to understand Einstein, and it messes up the ether concept. And that's the end. Thank you. That's the end of this little clip highlighting that Einstein's theory, special relativity, was initially rejected because of the problem of ether. The British wanted an ether theory, and since Einstein did not seem to be advocating an ether theory in 1905, he was initially rejected. Thank you. The end.